So let's think about this. No, I tell you what, I'll leave that there. Have a look at each of these triangles. Have a look at each of these triangles, okay? Now at the moment, sorry, I forgot to put the right angle in here. At the moment, what is the restriction on x? What is the restriction on the angles of x?
What do you mean?
So have a think. In each of these triangles, is there an upper bound or a lower bound for what x could be?
No. I don't understand the question.
Okay, so x at the moment, could it be any size you like? So we've got x down here to be 25.38 degrees. We've got x here to be 45 degrees. For this one, we've got x to be 30 degrees. Is there a restriction on the size which the angle could be in each of these three triangles?
Yes.
What is the restriction?
I don't know.
Okay, so could x be 0 degrees?
I don't think so.
No, tell me why.
Because it's a triangle, it should be more than 0.
Well, it's a triangle, so it's got to have three angles, right?
Yeah.
It's got to have three angles. So if this was 0 degrees, for example, this is already 90, it's a right angle triangle. What would this one have to be if this was 0? It would have to be 90. And you know that 90 plus 90 equals... And that's already what angles in a triangle have to add up to. So in other words, you wouldn't have three angles because 0 degrees isn't an angle. It's just a straight line, yeah? Is there an upper bound for what it could be? So lower bound is kind of anything above 0. Is there an upper bound for what it could be?
360? No. 180 or 90.
180 or 90?
I'm not sure.
Okay, so we know the lower bound has got to be 0, but not including 0. What I want is an upper bound, What do you reckon? 180.
So this is an upper bound in the triangle itself.
Yeah, so it's an upper bound of x. So what is the biggest possible thing that x could be?
89.
Right, I agree with Ahmed. Now, Batakan, you said 180 or 360, didn't you? Okay. Now, you know that angles in a triangle have to add up to 180, right? Which means that you can't have an angle being 180, because then what are the other two going to be equal to? You don't have three angles anymore, yeah? Now, are you happy that the upper bound is actually 90 degrees? Not including 90 degrees, it could be 89.9999999. It's not including 90 degrees, but anything up to 90. Convince me why.
Because we have a right angle already, which is 90 degrees, and we can't have another angle more than 90 degrees, because that means they add up to more than 180.
Absolutely right. So if you didn't catch that, you've already got an angle which is 90 degrees. Talking about right angle triangles here in trigonometry. Okay? We've already got an angle which is worth 90 degrees, which means that the remaining two angles have got to add up to 90 degrees. Okay? Now clearly, if one was 90 degrees, what's the other one going to be equal to? You're stuck, right? So it's got to be less than 90 degrees. It's got to be less than 90 degrees. Even if this was like 89.9, this angle could still be 0.1 degrees. You'd still have three angles there, right? But are you happy it can't be 90 degrees? Okay? So at the moment, if we consider right angle triangles, everything that we've been doing up to now with trigonometry, we have this restriction on the size of the angle. Okay, the size of the angle. In other words, it's got to be between 0 and 90 degrees, but not inclusive. Not inclusive. Okay? If you wanted to do this in radians, what would it be? Pi over 2. Okay? So in other words, if you are dealing with trigonometry in right angle triangles, there's a restriction on the size of the angle. Now, mathematicians don't particularly like this. Okay? If there's restrictions going on, you're like, how can we break this? How can we make this a little bit more interesting, right? So what if I wanted an angle which is 0 degrees? Does sine of 0 degrees actually have a size? And likewise, what about sine of 90 or cos of 90 or tan of 90? Or what about angles bigger than 90 like 360 or 720 or 135,000, right? So this is what mathematicians really wanted to build on. So at the moment, we've got a tool for working with angles between 0 and 90, but are you happy that for angles which are equal to 0 or 90 degrees or bigger, this tool breaks down? So we need a new tool to access this. Make sense? Right? That's what we're going to start talking about today. So can I just rub this side of the board off? Okay. So can you make a copy for me of this? It's literally just a circle. which is centered at the origin. So the tool which we're going to access to get angles which are bigger than 90 degrees, or 0 to 90 degrees, 0 degrees, 90 degrees, even negative angles, is using this idea of the unit circle. Now all the unit circle is, it's centered at the origin, and the radius is 1 unit long. So that means that this point over here has got to be 1, 0, because that radius has got to be worth 1. What's this point up here? Perfect. Somebody else, what's this point over here? Somebody else? York, what do you reckon?
Negative 1, 0.
Perfect. What about this point down here?
0, negative 1.
Perfect. Okay. So just by considering the intersection points of this graph with the axis, are you happy that we have a unit circle? Unit circle. Okay. And just to make it extra clear, this is the x-axis and this is the y-axis. Okay. So you're probably looking at me a little bit weird, and you're like, yeah, but what circle's got to do with triangles, right? What circle's got to do with triangles? So I need to find some right angle triangles buried within this so that I can think about trigonometry. Has anybody got any suggestions for where I could find right angle triangles in here? Nope.
I mean, we can connect the 2 points. The 2 points, the 1, 0 and the 0, 1.
Okay, so connect those points together. Okay, that's a good idea actually. So I could definitely connect those 2 points together, then I get a right angle triangle. Okay, it's not actually what I'm going to do. Not actually what I'm going to do. What I'm going to do instead is I'm just going to pick some random point on the circumference of the circle. So I'm just going to choose that one. But are you happy I could have chosen it over here, down here, down here? It doesn't matter where I choose it. I could have even chosen that point or that point. Okay, I've just chosen some random point on the circumference of the circle. Now, because it's a random point, it means it's just going to have some x coordinate and some y coordinate. I'm just being general here. Okay, it's just going to have some x coordinate and some y coordinate. It's just lying on the circumference of the unit circle. Okay, right? And then what I'm going to do is I'm going to join this point to the center. Okay, because I know the distance from the center to that point. What is it?
The radius 1.
Exactly, the radius is 1. It's just the unit circle, right? Now can you see that I've got a unit circle in here? Okay, because if I drop this perpendicular down here, and if I think about the distance which I've moved across by, okay, of course this is on the axis, just drawn it a little bit above to make it clear, okay, would you be happy that now I have my right angle triangle which I'm looking at? Yeah? Okay. Okay, let's think about distances then. What would the distance be from here to here? From here to here? We do. It's just x, isn't it? The distance from there to there, by definition, is whatever the x coordinate is. Whatever the x coordinate is. Yeah? What about this distance from here to here?
Y.
It's y. Perfect. Okay? So literally, because this is some random point on the circumference of the circle, we know that when we think about this, this right angle triangle, the distance we've moved across by is whatever the x coordinate is, and the distance that we've moved up or down by is whatever the y coordinate is. So all that's missing now is an angle, okay? Now this is the angle which I'm going to look at. I am going to look at this angle in here. Now just remember, angle is just really a measure of turn, okay? In other words, it's the amount which I've turned through from the positive x-axis anti-clockwise. Let me write that down. So this is my angle. Let's call it theta, okay? That's the angle I'm interested in. And just by definition, I'm going to call theta the angle which I've moved through, okay, so the angle or the amount of turn which I have moved through, okay, I've moved through it anti-clockwise. You happy it's against the flow of the clock? So anti-clockwise, okay, and where did I start from? I started from the positive x-axis. That makes sense? So literally I start here, then I rotate through that angle. Okay? So you move through anti-clockwise from the positive. Okay, positives on this side, negatives on this side, so positive x-axis. Okay, oops.